Let's go through lesson 4.7, sequences and functions. A sequence is an ordered list of numbers, like this one right here, that forms a pattern. Each number in the list is called a term. So this right here is a term. Each of those larger black numbers there is a term. The patterns can be anything like adding, subtracting, multiplying, or dividing. That can be any of those. Now, what you're going to do in your homework today or tomorrow is you're going to be identifying the pattern and then naming a few of the next numbers in the sequence or the next few terms in the sequence. So for example, if you look at this one, you'll identify what it's doing each time. And in this one, it's adding 6, so you'll say that. You're describing the pattern with that statement. And then it asks for the next two terms. So if you add 6 to 23, you'll get 29. And add 6 to that, you'll get 35. You should pause the video right now and give the next one a try. You should have chosen divide by 2 or multiply by 1/2. If you multiply by 1/2 or divide by 2, your next number in the list would be 25, and then after that, 12.5. Pause the video now and do the next 3. This one you should notice that it's adding 4 each time. If you add 4 to -3, you would get 1. And if you add 4 to 1, you'll get 5. In this one right here, you'd be multiplying by -2. You can also, by the way, write out the word add, multiply, divide. You can use the word for any one of those. If you multiply by -2 next, you'd get positive 32, and then negative 64. You would then, in this one, you notice it's adding 3 every time. So you'd have 17 and 20. In the next section, we have an arithmetic sequence. Arithmetic sequences. They are a type of sequence, a specific type of sequence. They show a constant common difference. They are what we would call, they're like our linear patterns. So our linear patterns show a constant common difference. They look like they're always adding. Now they might look like they're subtracting because they add a negative number too. They either add or they add a negative, so they look like they are subtracting. So if you look right here, if you see it going from 2 to 8 to 14 to 20 to 26, the common difference is a 6, adding 6. Here, the common difference is a -5. We wouldn't say subtract 5 here when we're talking about arithmetic sequences. We don't say subtract 5. We say the common difference is a -5. So when you're asked to give a common difference, you don't say the words add or subtract. You say a positive or a negative number in return. That's the only thing that you want to kind of be aware of, is that when giving a common difference, you tell the number that is the space between them or that positive or negative number you would have added. So we look at this first one here. It's asking you, is it arithmetic? So when you're answering the question, is it arithmetic, it's asking you, is it a common difference? Is that space between every number the same amount every time? And then if it is, you'll say what that amount is. If it's not, you just say no. So if you look at this one, the difference between 8 and 15 is 7. The difference between 15 and 22 is 7. The difference between 22 and 30, though, is 8. So you would say no, and then you would just be done with that one. The next one goes from 7 to 9, so it's 2. 9 to 11 is 2, and 11 to 13 is 2. That one's arithmetic then, so you would say yes. And that says, what is that common difference? It's that positive 2. So I usually write a semicolon and then say 2. Pause the video right now and write down your answers to the next 3. In this one, if it's going from 10 to 4, it's a -6. From 4 to -2 is also a -6 common difference, and from -2 to -8 is a -6 common difference. So this one we would say yes, and we say that the difference is -6. If you're ever struggling to find what that common difference is, you can just go backwards and subtract. So if I went backwards and said 9 minus 7, I would get 2. If I go backwards and take 4 minus 10, I would get a -6, my common difference. Right here, it goes from 2 to -2, and then from -2 to 2, and then from 2 to -2. That is not a common difference. It's not the same number every time. That is a no. This one right here, you would get -4. So this one is a yes. When you're asked to describe a pattern, it can be anything, adding, multiplying, dividing, or subtracting. When you're asked to describe an arithmetic sequence, it has to be a positive or a negative number as the space between any two. Turn the page. We're going to talk about writing the rule now for an arithmetic sequence. Draw an arrow underneath the word rule and write the word equation. Just as a reminder, when you're writing a rule, you are essentially just writing an equation. You'll notice that that equation right there looks kind of familiar. It's y equals mx plus b. We talked about this before. We have that beginning value, and we have that reoccurring value, that one that will occur many times over. So the beginning value is like the 0th term. It's the number that would be with 0 in a table. That reoccurring value would be our common difference. We've talked about it before as if we had a table. If you had 1 and 2 and 3 like that, it would be that rate of change in between any two values as you work your way down that table. So when you look at a list of numbers like this, the one thing you have to be aware of is that this is like the first number in the table. So add this to your notes right here. 7 is like the first term. 11 is the second term. 15 is the third, and 19 is the fourth term. You don't have the number you need out here as your 0th term. You need to put the 0th term on there. So you're going to have to kick back a step and find that. So you say to yourself, well, I know that the difference, the common difference here, is it keeps adding 4 every time. So what number would sit here if I were to keep adding 4? What number would be there logically for me to add 4 to it? It would be 7. That would be a 3. So this right here is a positive 3. If it had been a -3, I would say -3 right there, like a subtraction. And I notice that that rate of change is 4, 4, 4. So I'll say 4x. 4 for every step. And then just have y equals 4x plus 3. And that's how you get your rule. Let's take a look at the next one here. I want you to pause the video while you decide what is the 0th term and what is the rate of change. Pause the video while you do that. Your rate of change should be, oh, darn it, that should have been a 38. I apologize. So your rate of change should be, typo, that it keeps adding 9 every time. If it keeps adding 9 every time, this should be a 2. If it keeps adding 9 and that's a 2, then your equation would be y equals 9 is the reoccurring value, 9x, plus 2 out on the end. Now I'm going to show you something else that's not printed here. You definitely need to know this though. It comes into our word problems and it comes in on lots of different places. This is the first term, the second, the third, and the fourth. You can find any term you want by just plugging in a number for x. So let's say I wanted to find the 20th term, or maybe just the 10th term. You could find the 50th or the 100th. You just take that number and plug it in for x now. That's the beauty of having found this equation or this rule. The rule helps you then find any number in the list without continuing the list out forever. So let's say I want to find the 10th term. circle that, write the 10th right there. And let's find the 10th term and say 10, or 9, I'm sorry, times 10. You can write a dot for times or parentheses, plus 2. That would be 90 plus 2. And the 10th term is 90 then. You would get 90 as your 10th term. When you plug in 10 for x, gives you back 90. I'm going to pause the camera right now. You should pause your camera, I'm sorry. And you should figure out the rule for this one. There are no typos in this one. So you look here, you should see that it keeps getting lower and lower down the number line if you're thinking of it like that. You've got the first term, the second term, the third, and the fourth. You need to find the 0th one, that one that would be your starting point, your beginning point. So if it keeps dropping by 4 every time, your common difference is -4. The number that would be sitting here that you would say this minus 4, that would be a 1. So your rule is y equals -4x plus 1. Let's say I want you to find the 20th term this time. Pause the camera and find the 20th term. You're going to take y equals -4 times 20 plus 1. Show your order of operations, so multiply before you add. -80 plus 1. You'll have -79. If you were to continue this pattern out, the 20th number in your list would be -79. This is usually what I'm asking for. And then every once in a while I'll say, what's the 20th term? And you'll show some steps and you'll have that to go with your answer. Kind of depends on what we're doing. Now in this word problem, we're going to do both. I think I will do both. Let's see here. It says, after one customer buys a set of tires, the garage recycling bin has 20 in it. I think I'm going to start with a table. So this is like customers and this is tires. One customer, there's 20. After another customer buys a set of 4, the recycling bin now has 24 in it. So they just keep adding 4 for each car. Makes sense. Write a rule to represent the number of tires. So we're going to write our function rule to represent the number of tires. And that says how many would be in there after 9. So the first thing I need to do for my rule is I need a common difference. I've got that. I need to know what number would have been with 0. So I'm going to go back and find out what number were in there before the first customer. So if I keep adding 4 every time, that would have been 16. Y equals 4x plus 16. Now pause the camera the video while you find out what would be the 9th one in the list. You'd have 4 times 9 plus 16, 36 plus 16, and 6, 2. You'd have 52 tires. Like that. So you'll see word problems when you do your homework assignment. You'll see some where you're just writing the rule. Some it'll say, have you write the rule and do this. Today what you're going to do, though, is you're going to work on a quizzes to go with this. Okay? That will be in Google Classroom for you.